In this video, I'm going to talk about Le Chatelier's principle. Le Chatelier's principle basically states how a chemical system will respond to stress. And on a chemical system, there are three main sources of stress, and those are concentration change, temperature change, and pressure change. So a change in any of those three factors will induce stress into the system. I will talk about each source individually, but it follows the same logic. So it is good to think of the Chatelier's principle as a balance. So one side is going to be heavier than the other one, and it's just trying to make it even and just like equal, meaning that it wants to reach equilibrium. So the way it does that is it's going to switch the side that is heavier into the side that is lighter. So that means you could deplete this side, the side that is heavier, or you could increase the concentration or whatever on the side that is lighter so that it evens out. And that is what the principle is trying to do. So let's start with concentration. So first, if you have an increase in concentration, that is going to lead to the opposite shift, making the excess get depleted. So always remember that what is going to happen to reach equilibrium is the opposite of what you did. So if you increased the concentration of the reactant, you will have to deplete that concentration to get the balance to even out. Or another way to think about it is increasing the concentration of the reactant. To even it out, you would have to also form more product. This is instead of taking out the reactant you just added. On the other side, if you decrease the concentration of the product or the reactant, that is going to lead to replenishment. So like what happens when you increase the concentration, when you decrease it, the opposite is going to occur, and the system is going to replenish that deficiency. So let's say we have this example. We have N2O4, and that is in equilibrium with 2NO2. In the case we add NO2 to the system, that is, we increase the concentration of the product, let's consider this as a balance. It's in equilibrium right now, so it's all even. But when we add the NO2, what is going on is it's making the product side heavier. So NO2 would be heavier than there's a higher concentration of NO2 in the system than of N2O4, and so the system is going to shift it, depleting the excess of NO2 and reaching again equilibrium. Now let's go to temperature. Okay, so temperature now. Like I said before, all three sources follow the same logic. Always think of the balance. However, when we're talking about temperature, we have two different cases. The reaction could be endothermic or the reaction could be exothermic. When we have an endothermic reaction, we know that heat is part of the reaction. You need heat to be absorbed for the reaction to occur. So heat is part of the reactants. If you have an exothermic reaction, you will form heat. So heat is in the product. So you will have to write heat in your balance in the reaction, and depending on what you see your enthalpy to be, if it's negative it's exothermic, if it's positive it's endothermic, and you will know where heat is, either the reactants or the products. So like before, we could have an increase of temperature or a decrease of temperature because we're measuring that change. So when we have increase, that will lead to the favoring of the energy absorbing direction. When we have a decrease, we will favor the energy producing direction. So a very easy way to remember this is, so you increase temperature, that means that it's gonna get hotter, right? So you want to turn it down. You want to get it cooler. So you're turning down the heat. So when you increase, it's the opposite. You want to lower it. When you decrease, it's getting too cold, so you want to turn up the heat. So you increase it. So just think of it being as an opposite shift, like before. So let's say now we have a positive enthalpy. So delta H is going to be, I don't know, 40.8 kilojoules. So that makes this reaction endothermic. And we're going to use the same reaction as before. We have N2O4. We know that heat forms part of the reactant. So we write it here, plus heat. And then we're going to have the equilibrium with our 2NO2. So this is our balance right now. So let's say that we want a decrease in temperature for this example. So we're going to favor the energy producing direction. The energy producing direction is going to be when the heat is part of the product. So you could see this reaction this way instead of from left to right. So right to left, you're going from 2NO2 to N2O4 plus heat. So right now, this is heavy. This side right here is heavy because it's favoring it. So you have it like this, and what you want to do is just go to the left, opposite. We can make this really simple with the turn up the heat and turn down the heat. So we said in a decrease, you're lowering the temperature, it's getting colder. So what you want to do is turn up the heat. So what you're going to do is favor, just like add more of the side that has the heat on it. So you're gonna form more of this right here, which is what I did in this part. So the arrow is gonna go from right to left. So now let's look at the case of an increase in temperature. So we will start with the same, and it's still endothermic, so heat still on this side, and it's in equilibrium with the 2NO2. And because we want to increase the temperature, let's just think of it in the simple way. This reaction is gonna get hot because you're increasing that temperature, so you want to lower it. You want to turn down the heat, meaning you're going to form more of the other side. So this is gonna be heavy, like this, and you're going to go to form more 2NO2. Finally, let's go to pressure. So, same logic. Having an increase is going to bring a decrease of the opposite. So, if we increase the pressure, that is going to lead to favoring the side with fewer moles of gas. Because we're increasing pressure, so what we want to do to reach equilibrium is to relieve that pressure. So we're going to favor the side that has less gas to form more. And then if we decrease, you want to get more pressure for it to reach equilibrium, so you favor the side that has the most moles. And of course this only works with gases because it's pressure. So same reaction, and we're going to do an increase of pressure. We have N2O4 and 2NO2, and these are two gases. These are balanced. So in the reactant side we have 1 mole, in the product side we have 2 moles. increasing pressure is stressing the system. So to get it back to equilibrium, what you want to do is to form more of the one you have least. So right now the balance is looking like this. It's too heavy on the right side, so you want to increase more the side that has the least, and that is the reactant side. So basically, as soon as you understand the logic behind the principle, this should all make sense. All three of the sources follow the same logic. So the system gets stressed, and you have to find a way to get it back to equilibrium. And that was this video. Thank you for watching it. I hope you liked it and found it useful. And if you did, please subscribe to see more videos like this one.